Dear students, now we are going to see the course Signals and System. Under that, the topic is Classifications of System. Upon the completion of the course Classification of Systems, the students will be able to classify the continuous time systems based on properties and able to classify the discrete time system based on the properties. Classifications of systems. Systems are generally classified into continuous time and discrete time system. Both the systems are further classified into linear and non-linear system, static and dynamic system, time invariant and time variant system, causal and non-causal system, stable and unstable system. Continuous time and discrete time system. A continuous time system is a system that operates on a continuous time signal and produces a continuous time signal as the output. The system is symbolically represented as x of t is the system, and the system has a transfer function t, and the output is given as y of t. Discrete time system operates on a discrete time signal and produces another discrete time signal as the output. X of n is the input and the transfer function is t, y of n is the output. Linear and non-linear system. A system is said to be linear if it obeys the superposition theorem. Superposition theorem states that the response of a system to a weighted sum of signal is equal to the corresponding weighted sum of response to each of the individual input signal. The condition for linearity in continuous time system is transformation of a x1 of t plus b x2 of t is equal to a y1 of t plus b y2 of t. Here y1 of t and y2 of t are the system output or the responses. X1 of t and x2 of t are the system input. The condition for linearity of a discrete time system is transformation of a x1 of n plus b x2 of n is equal to a y1 of n plus b y2 of n. Here y1 of n and y2 of n are the system response of x1 of n and x2 of n respectively. Non-linear system. A system is said to be non-linear if it does not obey the superposition theorem. Condition for non-linearity in continuous time system is transformation of a x1 of t plus b x2 of t is not equal to a y1 of t plus b y2 of t. Here y1 of t and y2 of t are the system response of x1 of t and x2 of t input respectively. Condition for non-linearity in a discrete time system is transformation of a x1 of n plus b x2 of n is not equal to a y1 of n plus b y2 of n. Here y1 of n and y2 of n are the system response of x1 of n and x2 of n input respectively. Static and dynamic system. Static is also called as a memoryless system. Dynamic system is also called as a system with memory. A system is said to be memoryless or static if the response of the system is due to the present input alone. Example, in a continuous time domain, y of t equal to 2x of t or y of t equal to x of 2t x suffix 2 of t plus x of t. An example in discrete time domain is y of n equal to x of n or y of n is equal to x suffix 2 of n plus 3x of n. Dynamic system. A system is said to be memory or dynamic if the response of the system depends on the factors other than present input also. In continuous time domain, y of t equal to 2x of t plus x of minus t or y of t equal to x2 of t plus x of 2t. In discrete time domain, y of n equal to 2x of n plus x of minus n or y of n equal to x2 of 1 minus n plus x of 2n. Time invariant or shift invariant and time variant or shift variant system. Time invariant system. A system is said to be time invariant if the relationship between the input and output does not change with time. In continuous time domain, if y of t equal to transformation of x of t, then transformation of x of t minus t naught equal to y of t minus t naught should be satisfied for the system to be time invariant. In discrete time domain, if y of n equal to transformation of x of n, then transformation of x of n minus n naught equal to y of n minus n naught should be satisfied for the system to be time invariant. Time variant system. A system is said to be time variant if the relationship between the input and output changes with time. Continuous time domain, if y of t equal to transformation of x of t, then transformation of x of t minus t naught is not equal to y of t minus t naught. That should be satisfied for the system to be time variant. In discrete time domain, if y of n equal to transformation of x of n, the transformation of x of n minus n naught is not equal to y of n minus n naught should be satisfied for the system to be time variant. Causal and non-causal system. A system is said to be causal if the response of a system at any instant of time depends only on the present input, past and past output, but does not depend upon the future input and future output. For continuous time system, example of causal system is y of t equal to 3x of t plus x of t minus 1. And for discrete time system, example is y of n equal to 3x of n plus x of n minus 1. Non-causal system. A system is said to be non-causal if the response of a system at any instant of time depends on future input and also on the present input, past output. For continuous time non-causal system, example is y of t equal to x of t plus 2 plus x of t minus 1 and y of t equal to x of minus t plus x of t plus 4. For discrete time non-causal systems, y of n equal to x of n plus 2 plus x of n minus 1. Stable and unstable system. A system is said to be stable if and only if it satisfies the bounded input and bounded output stability criteria. BIBO stability condition for a continuous time system is every bounded input yield bounded output. The impulse response should be absolutely integrable, that is integral minus infinity to infinity. H of tau into d tau value should be less than infinity and greater than 0. If the bounded input and bounded output stable condition is not satisfied, then the system is said to be unstable system. The BIBO stable condition for discrete time system is every bounded input yields bounded output and the impulse response should be absolutely summable. That is summation of k equal to minus infinity to infinity. Modulus of h of k value should be greater than 0 and less than infinity. If the BIBO stability condition is not satisfied, then the system is said to be unstable system. Quiz question. The standard form of LTI system does time invariant system as linear time invariant system. Thank you for watching.